Hi, it's Mr. Benson here with the next video where we're going to look at quadrilaterals and their properties. So this is 5.6 in the text on page 176. So after this we want to be able to name and classify quadrilaterals, which depends on their sides and angles, and we also want to be able to do some calculations based on the interior angles of quadrilaterals. Okay, so let's have a look at what we mean by quadrilaterals. So here are some examples, and a lot of these shapes are things that we're pretty familiar with already. And so quadrilaterals are any two-dimensional closed shape with four straight sides. So there are just some simple examples. So when we're classifying quadrilaterals, the first main group that we look at are the parallelograms. So these quadrilaterals are parallelograms, and the reason for that is that we have pairs of parallel sides. Now, the way that we denote parallel sides, we do this little arrow, sort of arrowhead symbol, whoops, on the lines there. That's a terrible colour, isn't it? So we can see on our rectangle over here that we've got pairs of parallel sides. And then on the, so this is actually what we would call a parallelogram as the shape itself. We've also got pairs of parallel sides on this shape as well. So the parallelogram shape itself is the is kind of the one that defines that class. So what we've got is opposite sides, so those opposite pairs of sides are equal in length. So we can look at the length of this side here and the length of this side here. And then we also have opposite angles being equal in size. So if we look at this angle here and we look at this angle here, they are equal, and then the other pair of angles are equal as well. So that's the definition of a parallelogram. Then a rhombus is essentially just the same as a parallelogram, but we've got all sides now being equal in length. So you can see that all four of our sides are equal, but our angles are still in pairs of equal angles. Now a rectangle is like our parallelogram, but all we're doing is changing the shape of it by adjusting the angles to 90 degrees. So we still have pairs of sides that are equal, but they're the opposite sides that are equal to each other in length, but all the angles in the rectangle are right angles, so 90 degrees. And lastly, the square is the most symmetrical one now, where we've got all sides are equal in length and all our angles are the same size. They're all right angles at 90 degrees. Other quadrilaterals can have no more than two parallel sides. So at the most, they're going to have two parallel sides like this quadrilateral here. So the trapezium has one pair of opposite sides that is parallel, and that's the definition of a trapezium. So the angles don't actually matter. So you can see in this trapezium here that actually all our angles are different. So this angle is not the same, this angle is not the same, and this angle is also not the same. So we're getting a whole lot of little arcs there. And that is a trapezium, whereas the one that I showed you on the previous page did have some symmetry in its angles, but that is also still just a trapezium. It's not a different shape in any way. So with trapeziums, all you've got to worry about is one pair of opposite sides being parallel. A kite is another irregular quadrilateral. So we've got two pairs of adjacent sides of equal length. Now, we used the word adjacent previously, and adjacent just means next to. So we think about pairs of sides that are next to each other. So we've got these two sides here are adjacent, and we can see that they have an equal length. And then down here we have these two sides are adjacent, and they also have the equal length there. Now we also have a pair of opposite angles between the adjacent sides which are of equal size. And if we have a look here, we've got the angle which is between the sides of unequal length, and then opposite that we have another angle which is also the same size. And lastly, we end up with the irregular quadrilaterals, and they have no specific properties. So they don't fit into any of the other groups. So they've got no pairs of parallel sides, and they are not going to have any angles that are the same either. So one thing that we want to be able to do is perform some calculations on the angles in quadrilaterals, and we can figure this out if we remember the idea from our previous video that the internal angles in a triangle all add up to 180 degrees. So we'll keep that in mind. So here's a nice quadrilateral. It's just a nice simple parallelogram. Now if we divide that in half, we've created two triangles. Now, if I put the angles in each of our triangles, so there's our first lot and there's our second lot, well, we know that the angles in a triangle have to add up to 180. So our first triangle up here, we know that these angles add up to 180 degrees, and the one down here, we know that these angles add up to 180 degrees. And you can see, particularly on these vertices at the end, that the angle in one triangle here is just adding to the angle in the other triangle there in order to make up this larger arc here. So what we can figure out from that pretty easily is that all the angles inside a quadrilateral must equal 360 degrees. So writing that a little bit more nicely. So this is something that again you want to put in your reference books and possibly have on reference sheets and that kind of thing. The interior angles in a quadrilateral add up to 360 degrees, and if we've called our angles A, B, C and D, then we would just say that A degrees plus B degrees plus C degrees plus D degrees equals 360 degrees. Quick example, find the size of angle B. So we're just going to go with what we know from that previous question. We know that these four angles add up to equal 360. I'm just going to write the numbers here and I'll put the degree symbol in later on. So what I would say is B plus 120 plus 80 plus 75, excuse my slightly scribbly writing here, equals 360. Then I can evaluate what the left-hand side adds up to. So B plus 275 equals 360. So then I've just got to figure out what B equals. So what plus 275 equals 360. The way I'm going to do that is go, well, if B plus 275 equals 360, then B must equal 360 minus 275, which is 85 degrees. And that's my answer. In summary, we have that quadrilaterals are closed shapes with four straight sides. Parallelograms are the main class of quadrilaterals, and they have two pairs of parallel sides, but make sure that you're familiar with the particular shapes, so the parallelogram itself, the rhombus, the rectangle, and the square. Then we have other quadrilaterals that have no more than two parallel sides. So our trapezium has two parallel sides. Our kite has no parallel sides, but it does have some sides of equal length and some equal angles. And then we had our irregular quadrilaterals that really have no common sides or angles necessarily. Then the last thing we looked at was being able to do some calculations in relation to angles. We could see from what we previously knew about the interior angles of triangles adding up to 180, that the interior angles in a quadrilateral must add up to 360 degrees. So again, attempt the exercises, check your answers. If you're getting everything right, move on. If you're making mistakes, practice some more and seek help from your classmates and then your teacher if you need it.